So we've developed these relative permeability cheats for you guys, such that every time you work with a numerical model, do numerical RTA, etc., and you're dealing with trying to match producing ratios over time, you have a little bit better basis or understanding at least of how changing some of these parameters will affect your producing GORs. We have provided both of these sheets in the show notes below, so both on LinkedIn and on YouTube in a PDF, so you can download them for your convenience, and they are also in the Whitson Plus manual. The reason why it's important is that every time we are dealing with a numerical model, we need rel perms as an input, whether we like it or not. So that can be during numerical RTA exercises or numerical modeling exercises. Unfortunately, for many of us, general relativity and relative permeabilities are almost viewed as equally abstract and complicated. So we try to, like, with these cheat sheets, bring that down to earth a little bit for you guys. So hopefully it'll be easier from now on. If you. A very important reminder is that producing ratios is a function of PVT and relative mobilities. Okay, and just a quick reminder for that. This is the equation for producing GOR. And as you can see in front of me, this is producing GOR, this is a PVT term, this is a PVT term. This alpha right here, that's this guy right here. This is a rel perm term, and these are PVT terms. So it's you can say that producing ratios is a combination of relative permeabilities and PVT properties, okay? And once you have defined a PVT for a well, you can say that changing rel perms, and especially the mobility ratios that you find in rel perm curves, is kind of the second part of that equation. If you open up Whitson Plus, in the numerical model and numerical RTA, you would have to edit the relative permeability curves by clicking this button up here to the right. And you can also view how they look like by clicking this button right here. What you'll see as a starting point is the so-called default queries. And I always encourage people, use the defaults as much as you can. And if you're changing something, don't go in and change every single parameter. Try to maybe change one parameter, two parameters, or in some cases you have to change some a lot. But I'll show you a couple of parameters that are very effective if you're dealing with, for instance, wanting to alter the relative mobilities for GOR performance versus time, for instance. So what I typically do is that I typically start with the NG parameter, and moving that up, that would lower my GOR, and moving it down would increase my GOR. The second most used parameter for myself would be to change this SORG term. SORG can be thought about as like the critical condensate saturation if you're dealing with a condensate well. So if you're dealing with like near critical fluids in the Permian, for instance, that have very high liquid mobility, you go below the saturation pressure and the GOR almost doesn't increase. Well, that means that most likely this parameter is really low. So those are a couple of my starting points right here. And then I would say the SG term to the right here, that is a term that you should see in your producing GOR if this is needed or not. Okay, so if you're dealing with an oil well and the critical gas saturation should be included, then you should see a little bit of a dip in your producing GOR as you go below the saturation pressure before the GOR starts to increase. Else I would have just put this parameter to 0. There's a couple of the tips. The rest of the tips you'll find in the cheat sheets, and I encourage you to go into Whitson Plus, go to the sensitivities feature, play with the rel perm parameters yourself. Go into the sensitivities, pick a rel perm parameter that you are curious about for a fluid system that you are curious about, define a set of ranges of these parameters, and bulk run them and see how they would impact your producing GOR, and build this intuition yourself.